Hello, this is Network Technologies, Chapter 2, and this module is for infrastructure and documentation. This chapter describes cabling, how the cabling is done in a building or in a working area, maintain documentation of that cabling or any connections that you have, and also how to manage changes to a network. Like everything else in networking, there's a protocol, right? Protocol dictates the rules that you need to follow in order to get something standard with everybody else. So cabling also follows a standard that is dictated by the ANSI TIA, and it's the 568, the one that defines the building wiring, which is known as structural cabling. ANSI is the American National Standards Institute, and TIA is the Telecommunications Industry Association. So both of them together came up with this cabling standards. So everywhere you go, if everything is done to standards, they should be able to follow it, fix it, add to it, and improve it. The way that this standard is done is to lay down things in a very organized way and also to maximize performance in a way that it doesn't require any maintenance or a periodic maintenance to do on the cabling. Um, So the cabling, it's based on a hierarchical design. So the networks nowadays, they're all mostly a star topology. Remember that's when you have something in the middle and everything branches out from the center. So I'll create like a star topology. Now there's quite a few terms that are going to be introduced in this chapter. I'll go slowly with this. But when you get your services provider for your internet connection or any kind of services, either if it's voice, data, or broadband, when it mixes everything together, you'll have what's called your ISP. For those that don't know, the ISP is your internet service provider, right? So they'll bring the connection to your location, and it has to go to what's called the entrance facility. The entrance facility is the point where you're going to have the services coming in to your building. It's normally either well, it has to be on the first floor, right? And all these services are mostly brought in from underground, or they could also be aerial, and they bring it to the side of the building and bring it to the back. All those connections will go to what's called the MDF. The MDF is the main distribution frame. The main distribution frame is your center of your network. Remember that star topology? It would actually start at that MDF. Now, when the provider brings their connection, they will terminate their connection at a point, and then you take it from there, right? It's kind of like your cable company brings up your uh, uh, cable jack on the wall, and then from there you go to your modem. So that is called the demarc. That's basically your demarcation point. Demarcation point, it's that place where the services come in. So you got your entrance facility, which kind of the path when it comes in. Then they'll deliver the service and put a jack for you, smart jack or whatever they put in there, or even their own device. So that's called the demarc. And that demarc is going to be inside that main distribution frame room, which could be your data center, your data room, utility room, whatever they bring those services, it will be on your MDF. Now, from the MDF, you distribute your cabling and your services to other areas, and those are called IDF. The IDF is the intermediate distribution frame. Intermediate distribution frame because that's where you have all your equipment, your network equipment. If you see here on the left, you have, let's say, your data room that goes to your IDF, and the IDF then provides connection to everything in your working area. If you go to the right to building B, you see that you have your backbone, which is your connection from building to building. That also starts from NDF, so it's like a star topology, and it goes to your IDF, which is the final room where the distribution happens, and then get distributed to all the different IDS. And the same thing with building C. So here you have all the summary of those terms: your entrance facility, your demarc point, your MDF. Then you can have a data room. Now, all these places will have racks. Racks are just, we'll show you a picture later on. standing equipment frames where you install your equipment. So we will be what they call rack mounted because it's mounted on a rack. And then you have patch panel. The patch panel is, as the word says, is a patch. It's a patch where you connect a connection and it gets delivered to another connection. So that's how you patch it through to another connection. So that's where you receive the signal and from there get distributed to the different places in your building. But be familiar with all these terms. You always see it in IT. People tell you about the DMARC, the MDF, your IDF. Data room, yeah, that room is where you have your servers and things like that. So data rooms come in all different, colors and flavors. It depends how they have it. It could be a closet, your equipment room, your telecommunications room. Some people have it in a utility room, which is not a good idea. Utility rooms usually they have chemicals. If they do cleaning and things like that, they keep cleaning, cleaning with solvents and things like that in that utility room. That could also start promoting corrosion of the equipment and things like that. So you want to have your data room and your MDF completely separate. Another thing is cooling. A lot of this equipment, if you have your data room, they need to be cool at a certain temperature so your servers or your equipment doesn't overheat. Normally, you want to keep it like around 65 degrees, which is quite cold, and there has to be a low humidity too. So, but it could be between 65, 70 degrees. That's still a good temperature. But if it goes too hot, what happens is some equipment would actually shut down. Electronic equipment right now, if they have sensors, so even your home computer, if it overheats, if it goes too high, your phone, if you leave your cell phone on your dashboard and it gets, say, the straight sun from Miami, it will get to a point that the phone will shut down because overheats. It's a protection. It won't break it. It has its own protection that it will self-protect and shut down. But imagine if you have a server that provides services to your whole enterprise, and when it overheats and shuts down in the middle of the day, you don't want to do that. So what you want is your data room to be cool to a temperature that will maintain that equipment running at the correct temperature. And this is a good representation of that structured cabling following the ANSI standards. On the first floor, you see that you have your entrance facility. That's where it comes from the outside. It goes to your main distribution frame, which is your MDF. Like I said, normally it's on the first floor. And then you take it up to a second floor on what is called a vertical cross connect. Vertical because it goes vertical, right? Goes vertical, goes up to the second floor. And then from there, you have what is called the horizontal cabling. Is from that IDF on the second floor to the workstations. It's not, well, it's mostly horizontal because it still has to go up a little bit into your ceiling, or what it's called the plenum. Plenum is the space between the floor, the floor above, and your ceiling. There's always a space there, like a crawl space, where you have your drop ceiling or anything, that it is called the plenum. In the old days, actually the plenum word comes from plenum is the space inside your air conditioning ducts. What happens is in the old days, the easiest way to take cable into rooms, it was through the air conditioning. So they will throw the cables into the plenum, which was a space inside the air conditioning ducts, and then we'll bring it to the vent in that room, and from that vent, they'll take it out and just run it through the wall. Nowadays, you don't do that. You just lay down on the ceiling floor. I mean, on the ceiling, down on the ceiling, but that space between the concrete slab or the wood and the second floor or the floor above and your drop ceiling, that's called the plenum, and that's mostly horizontal, right? It will run mostly horizontal. Will go a couple feet up. It will go mostly horizontal across the room, and then where your workstation is, it will come down vertical again, but it's still, that's called the horizontal wiring. This is a typical DMARC for a small business. If you see to the left, you have an APC power strip, right? That's provide power to that, I guess, a router, that white router. And you have your ISP connection coming in, and then I guess it's on the yellow fiber. That's a yellow with green fiber. And towards the middle, you see a blue and a white cable. That's the white seems to be the power. And then the blue cable is the customer Ethernet network side. So the provider brings it in from the from that yellow fiber and light green, and then the blue cable will take it out. This is more for like a small bit, a small to mid-sized business will look something like this. If it's a large enterprise, basically they'll deliver the fiber directly to you, and then you take it with your equipment. This a router is sometimes is owned by the provider, AT&T, Comcast, or whoever is providing your network connection. Very seldom is owned by you. They're the ones that are to provide that, and that is your DMARC point. So when you call the provider and they're trying to troubleshoot, they say, have you looked at the DMARC? And if you see this is against the wall, so for the most part, the provider will ask you for a space on the wall, like a space is reserved only for them, where all the cables come in. If you see on the right, they're all nice tied together. That's probably for the power and everything else, and how they bring it in. And they also would ask you for the grounding, for the proper grounding. I don't see a grounding there. I guess it's out of the picture. It doesn't fit in the picture there, but yes, they will require you to have the proper grounding that is actually going to your, in our case, the FPL ground. So is together with your building ground, so the equipment gets protected. All these are pictures from your book. I think this is page 58 that will show a patch. This is a patch panel. A patch panel is just like an intermediate point where you connect your wiring. This doesn't show the picture of the back of the patch panel, but on the back of the patch panel, the wires are connected there, and I'm going to bring a patch panel to class. I can show you exactly how it looks like in the front and the back and how these things are connected. But if you see, they're nicely organized. They're tied together with a cable tie. Also, you see the numbers on the left. Those are the number. The U's. Every rack is labeled with. They're separated by a standard unit. So that's called a U. So that's the U 36, 37, 38, 39. And if you see, the patch panel on top is taking 2Us. So most of the equipment is either built like a 1U, a 2U, or a 4U, and it will take exactly that whole unit. You rarely will see something that will take half of a unit or like a 1.5. They're usually made in a way that either a 1U or a 2U. So that wire management, which is with the black cover in the middle, that wire management, of course, is a 1U. Because it's covering 38, and then 36 and 37 is the bottom patch panel, and 39 and 40 is the upper patch panel. And those seems to be like a 48 port, 24 on top, 24 at the bottom. You see the first one starts with 25 on the upper right. You see 1, 2, 3, 4, 5, 6, and then at the bottom it goes 25, 26, and it goes all the way to 48. So those are two 48 port patch panels. Most of the patch panels are 19-inch in width, so that's like a standard. There are two standards, but the one that is mostly used is the 19-inch racks, and also the height of the rack. Those used, it depends on which rack they have, but they could be anywhere between 18 to 22, whatever the size. But the normal industry standard, it's 42 U's. 42 U's is this unit. Is that they're not inches. They're not anything specific. It's a specific height, but they're called U's. So this rack, the normal racks are 42 U's. But I've seen even the 48 U racks, which is not a standard, but they're quite tall. So by following the structured cabling guidelines, then you can distribute your signal as it comes in. So if you have voice being delivered to you on your DMARC or your entrance facility, so you'll bring in that voice connection, and most likely it will be connected to a voice gateway, and the gateway will go to a PBX. Nowadays, you don't have a PBX per se. That was the old a public exchange for voice, and then from there it goes to your voice IP endpoints, which is your phones itself. That's for the telephony. If it's data, the MDF will send the distributed signal to your IDF, your intermediate distribution frames, and from there it goes to your work areas, right? And that work areas is your workstation, your printers, and everything else, anything that you have on the network. And that gets delivered to the wall jacks, right? So it goes through um, from the MDF to the IDF, either through a vertical wiring, right? To go up to a second floor, it goes to an IDF there, and that IDF goes through the horizontal wiring all the way to your work area, and then you terminate that connection on the wall. And that termination also should follow the 560A standard for the cable, and we'll go over that in a few slides. Now, this diagram represents the distribution of voice services. Your telephone company might bring in that into a voice gateway, right? And that's on the upper part. The voice gateway will deliver straight to a switch, a network switch. Remember, switches are layer 2 devices. They only know MAC addresses of the devices, and that will distribute that at from the IDFs to telephones, right? And you can have a voice over IP PBX now, or you can have the ISP providing a switch. Then you have your voice gateway, and that voice gateway can provide a legacy PBX to use a legacy phones for the analog phones. Nowadays, haven't seen that many analog phones anymore because voice over IP has become very, very reliable and very clear, and they have less problems. It's easier to fix, easy to expand. So a lot of companies, even in small places, are going to a straight voice over IP. In my house, I do have voice over IP, but I have a little kind of like a legacy device that will provide signal to the old analog phones. So even though I had voice over IP, it goes to this legacy, kind of like a personal PBX, because it's only for one or two phones. And then there I can connect the regular old cordless phones, and that I can have telephony all around my house with the cordless phones, and even though I have a voice over IP service, it's just that I have sort of like a legacy PBX in the middle, and that provides my connection to the legacy phones. Legacy phones, I mean in the old phones. Those are the analog phones, and that they don't have a phone jack in the back. I mean, they do have a phone jack in the back. The new ones will have basically a network jack in the back of the phone. Those are the IP phones. Now, this is the distribution for networking. You have in brown or yellow? No, it's brown. Your ISP, your internet service provider, it goes to your MDF. Your ISP will always, your provider will always go to the MDF because that's your main distribution frame, right? That's your main point of your network. And you see that it's like a star topology, and it branches out to the IDFs, and each IDF on itself, it becomes a star topology because they distribute to the phones. I mean, to the phones, phones or computers or anything else, in a star topology. So of course, there's some equipment here in the middle. We don't have it here, but you'll have switches and routers. Most likely, you'll have the router on the MDF. That's the one that'll separate all your networks. And then each IDF will have switches for your layer 2. Remember, routers are layer 3. So the IDF will have switches that are layer 2 switches, and they are the one that distribute the signal within your different areas, different floors. All right, I mentioned this on the racks before. The racks, the standard is a 42U tall. That's the U is that height of the each number that you saw there on the previous picture. They could be a wall rack. They could be ceiling mounted, freestanding on the floor. For the most part, you have it screwed down, bolted down to the floors for safety. So you don't put too much weight on the top or something like that. It can be tilted over. So they normally is screwed down to the floor. If it's a small place, a small enterprise, you'll have a rack that is mounted on the wall. And of course, that's not going to be 42U. It's going to be like an 18, 24, something like that. Some smaller U, depends on the equipment that you have in there and how many U's you require. For large enterprise, I think in our MDF at the college, we have, I think it's like about 5 racks on the first row and another 4 racks in the back. And those are bolted to the floor. And then behind those, we have 2 more racks. Those are freestanding. Those are more like cabinets with, kind of like feet at the bottom that for 4 posts, so they can freestand on the floor. So it's quite a few. You know, a data center, I mean, not a data center, an MDF can be quite large. Like I said, the width, the normal standard size of the equipment is 19-inch, right? The frame is 19-inch, so all the equipment has to be 19-inch. It is a standard, so all the equipment will come in. The equipment will come in on that size. If they're not that size, most likely they will have a tray that is 19-inch. So you install the tray, and the equipment goes normally screwed out into the tray, or they will have what is called the mounting brackets. The mounting brackets just kind of like just like an L-shaped metal piece of bracket that you screw it to the side of the equipment, and then it's exactly made so it can convert, you know, that to a 19-inch footprint, and you can install it into it. The depth varies on the manufacturers. You can have racks that are only like a 2-post standing, right? There's nothing in the back, so there's whatever, you can go as deep if you want it to hit the wall. So sometimes you have to be careful when you install those standing racks with the 2 posts that you install them with the proper distance to the wall, so it's a space in the back. If you have the 4 posts, which more like a cabinet, with the 4 post cabinets, then they come in different sizes, or some of them also adjustable, so they come in a large size, and then you can adjust the frame inside to get it to the size that you want. Okay, so here you see them. This is on the left. You see the 2 post racks. It has like a silver plate at the bottom. That plate is actually screwed on down into the concrete floor, and that will hold that rack standing up. And also, if I put 4 racks like that, most likely they will have another support on top that tie them all together. That way, they one helps to support each other. If you need to install a battery backup, the battery backups are usually heavy. A battery backup, it will be at least 75 pounds. It depends on the size of the battery backup. But some larger ones, of course, will weigh more than 75 pounds, but at least they will weigh 75 pounds. So when you install a battery backup, you want that battery backup to be at the bottom. And if you see at the bottom, there's a little lip, it's like about 2 inches height, that whatever you do, the equipment will not be right at the floor. It will be still above like about 2 or 3 inches of the floor. When I install UPSs, I always, even though I can put it all the way to the bottom, I try to raise it up a little bit more, just give it like another inch, for 2 reasons. One of them is cooling. Since it's not completely on the floor, and you raise it up a little bit, then you allow some air circulation within the bottom piece and the size of the UPS, right? And also, if there's a flooding, you will require at least 2 to 3 inches of water to actually reach the bottom of the first device. All the routers and everything and switches can install like in the middle. This one you see like almost everything is in the middle, and your patch panels are usually on top, or the lighter equipment is all the way is on the top. Equipment that you usually don't access all the time, right? And so once you got your fiber connection coming in, you connect once and you barely touch it again. So that goes on the top, but then all the heavy equipment you put it at the bottom. And if you have a server that's quite heavy, or a router that's quite heavy, there's some routers that could be like 80 pounds or more, then of course you want to have those routers more like between the bottom and the bottom half of that rack. So you don't have to put it on top, because the whole weight can tilt start hurting the screws and tilt over. So it's just for your own safety. On the right side, you see the cabinet. See, that's a cabinet. It's completely enclosed. Those will have some cooling. If you see on the front of those cabinets, it's a picture on the right, that the floor has little holes. That's because they're bringing the cooling from the bottom, from under the floor. A lot of the data centers will have cooling that's coming from under the floor. The floors are raised like about 1 foot or 1.5 foot from the actual concrete. All the cabling and power can go at the bottom, and then the air conditioners actually push at the bottom. You know that the nature of the hot air is to go up, right? So they will push all the cold air at the bottom, and then from the cold air at the bottom, it starts to raise up to the top, and it start cooling everything. So the equipment will come in with fans, so the fans will try to suck in the air to cool the equipment. So if you have light at the front of the rack, it will suck in all that cold air to cool the equipment, and it will push it to the back. So those cabinets that are right next to each other, cooling is very difficult. I mean, most likely what happens between like four cabinets like that next to each other is that you remove the panels in the middle. So all those panels are completely open from across. And then you just put the end panels on the at the edges, at the ends, right? But the cooling still has to go from front to back, and we'll see that on the next slide. All right, so on any data center or any rack installation, you'll have to what is called the cold aisle and the hot aisle. So here in the blue arrows, that's the cold air being pumped in, right? And then the red is the cold aisle. And you see how they have the color from blue at the bottom to red on top. That's because the heat always rises to the top, right? So that's why it's going to be hotter on the top and cooler at the bottom. Although, yeah, the air comes in from the front. So and look at these things like it's standing. Those are like standing racks. You don't when you look at these three bars of colors, imagine those are three standing racks. So when you put two rows, you have to make sure that they face each other. So the the first on the right side takes in the cold air on the right side and push it to its back, right, on the red arrows. So the other one, the one in the middle, you want to do the opposite. So they're both pushing the hot air in this and the same aisle, and that raises up. Why not the other way around? Well, you don't want that the other way around because you don't want the front on the left side, sorry, on the right side, suck in cold air, go through the equipment and heat it up, and then throw it into the next one behind it. And then that's going to be absorbing kind of like a warm air. It was going to heat it up even more and then push it the other way to the back and then to the third rack, and the third rack will get all the heat from everything. So that's why you need to have a cold aisle and a hot aisle. So what they will do, remember those um, uh, raised floor with the vents on the floor, then you had the vents where you see those blue arrows. So that's where the vents will be. So all the cold air comes in, and on the back of the racks, where the red arrows are, that floor will be completely sealed. So there's no air conditioning coming there. It's just being, sucked in. Okay, it happened to us at one time at Miami-Dade that we put three big routers, and they were like three racks next to each other, and there were two post racks, and they were just side by side. And the cooling on that equipment was left to right, not front to back. So that's the problem that we had, that the first one would suck in all the cold air, push it onto its left side as a hot air, but then that's the intake for the other one. So this one was absorbing, inhaling that hot air. It will heat it even more to start to cool itself, and then push it to the third one. So guess what? The third one was getting all the heat. So what we had to do was to stagger those. We'll put the one in the middle, like all the way to the bottom, and the one on the edges of the two racks towards the top. So that way there's still some buffer space, so they don't do that chain reaction of heating, pushing hot air from one to the other. So that way we're able to at least work around the problem. Okay, these are more terms that you need to see, you'll get to see in IT constantly. You'll get patch cables. Patch cables usually a short cable that has connectors on both ends and is due for patching, usually from a patch panel to a switch, or from the wall in your office to your computer. That will be a patch cord. They come in 3 feet, 5 feet, well, 3, 4, 5, anywhere between. Actually, I've seen half a foot, but normally you'll buy either 3 feet, and depends how long you need the connection, like about 15, 20 or something like that. And sometimes you don't want a patch cord that is too long, because remember it is adding to the total length of the cable, and later on we'll see why that's not a problem. Then you got the horizontal wiring. That's the one that connects to your workstation. Remember, that's within the floor to go to your workstations. And the backbone cabling is the one that connects all those MDFs and the IDFs, right? The main distribution frame to your intermediate distribution frames. Those are the ones that is called the backbone. Normally, backbones are fiber connections. For the most part, I would say like 99% of the time that is fiber. There are different types of fiber. Could be multi-mode, single mode. We'll go into that later on. But it's different types of fiber. But it depends on the situation, the distance and things like that, the specs that are required. But you'll have different types of fiber. But for the most part, is fiber. Why do I want to use fiber? Well, remember what I told about EMI, electromagnetic interference. If you have a wire, any wire that you extend on any open space is an antenna. Remember in the old cars that used to have your car antenna, it was sometimes it was just like a metal straight metal rod that go up for like about 3 feet, I would say. I can't remember how long they were, but it was like about 3 feet. Well, that big long rod of metal, it's an antenna. It picks up everything. If you see the old TV antennas, what did they had? It was this little uh, sections of metal straight, right, to pick up an antenna. So any cable that is held up in the air is picking up all kinds of things. So you don't want to have um, cable to connect on your backbone to connect, maybe to front and back. All right, this is more like a small diagram of a description of the horizontal cable. So from the data room or your IDF, it doesn't matter, what location would be. You have your switches, right? They will have the horizontal cabling that goes all the way to the data jack. That's the data jack on the wall. That could be up to like 90 meters. And then you can allocate like about 10 meters between the data jack and the workstation. Now, why 90 and 10? There's a limitation on Ethernet for 10 megs, 100 megs, and even for 1 gig that the limitation is 100 meters. No cable, not connection, can be more than 100 meters from end to end. From end to end, this is from the switch in that cross-connect data room to your workstation. And it's funny, it happened to me. Once you go to, and believe me, 101, 102 meters, you will have problems. The connection will drop, the connection will have errors, the connection will come on and off, on and off, on and off. It's like magic. You cut it down to 100 meters, and then magically everything works, because that's the limitation that it has. So when you plan your cabling, you have to be careful, because you cannot make everything 100 meters. Because once you put a patch cord, the patch cord will go between the data jack and your workstation. That adds to the connection on the horizontal wiring going to your data room, right? Is the total length, not just from one connection to the other, is the total length. So if I have a 15-meter patch cord, that will make it 105, and that will give me problems. For the most part, people use 5 feet, which is about 1.25 meters, like about almost 2 meters. So they usually is small patch cords, but then you'll get someone that'll get that big long 20 meter cable, 20 meter patch cord, and connect it from the wall to the computer, and then start wondering, why is my computer having problems? And it's because you have that limitation that you cannot go beyond 100 meters. And keep that in mind, because it will come up on your IT world over and over and over. When you test the cabling, you usually put a piece of equipment that will do the length testing, and it will tell you how much is the length of the, from end to end. And that's when you verify that the cable is no longer than 100 meters. So as a rule of thumb, make your connections for the horizontal wiring from the switches, all the way from the switches to your data jack, no more than 90 meters. Now, the most common cabling is done with either UTP cable or STP. UTP on the left is the unshielded twisted pair. You see that it has 4 pairs of wires. There's always 4 pairs, total of 8 wires, right? There's the orange, and there's the orange with a white stripe. You got the blue with the white blue, green with the white green, and brown with the white brown with a brown stripe. And all the cables are going to have those 4 main colors, and that's part of the 568 standard, that you need to have those. Those are the colors of the cabling. The shield itself, not the shield, the coating, the plastic coating can be any color. I mean, mostly it depends on the installer. Some of them prefer to do blue for data or gray. And traditionally, you'll do white for voice, but also gray is accepted for voice. But there's got to be a difference, for data and voice. Although now with voice over IP, the phones will use a data jack, so there will be a blue cable. But like I said, the plastic coating is just a coating. Color doesn't mean anything, but there's Also, you can stick to some standards to differentiate cables. So if I'm doing cabling for um, the energy management systems, for the or emergency systems, for alarm systems, then I'll use a different color so I can distinguish what cable is for what, although it's the same type of cable. But the strands inside are all going to be the same, orange, green, blue, and brown. So the one on the left is the UTP. It's unshielded twisted pair. It doesn't has a shield. It's just the four pairs of wires twisted together and over the sheeting of the wire. Now on the right hand side, you got the shielded twisted pair, and if you see at the bottom, by where it meets the plastic on the blue, there's a little foil. That foil provides a grounding for cables that is susceptible to a lot of interference, or areas that have a lot of interference. When you run cabling, you don't want to run over fluorescent lights and things like that, because fluorescent lights actually generate a lot of EMI, and you want to stay away from that. Running cabling across on top of a kitchen where there's a microwave, you want to avoid that area. You want to go around that kitchen because you don't want to be too close to that microwave. If you have any motors, you want to also run your cable away from those motors, because all the motors generate a lot of EMI, and you want to stay away from that. Power lines, even your regular power lines, you don't want to run your data and your power together, because it will create interference. So even these cables themselves, the data cable, those connections will create what's called a crosstalk between one pair and the next pair. That's why those pairs are twisted together. That twist helps minimize the noise, what's called the crosstalk between one set of wires and the other set of wires. Okay. So this is the full path of a cable. It comes, you see the backbone, coming in from the MDF, comes into the switch. The switch feeds the patch panel. The patch panel is just is a intermediate point. So you have like a quick connect and disconnect. So it doesn't have to go directly into the switch. So the switch, it goes, patch into the back of the patch panel, and the front of the patch panel. It might go to a walled patch panel. Either in the old days, it used to be a 110 block. Now you don't. So nowadays, usually you go straight from the patch panel, like in the rack, is straight into the wall jack. You wouldn't go through that one that shows here in the wall. But this is just to show you, the steps that it can do. And it will go through that horizontal cabling, although here it's just going down. Remember, horizontal because it's going across a floor, across a room, from corner to corner, from side to side. So that's horizontal. And it goes to the wall jack. So that's where you want to have 90 meters from the wall jack to the switch. So you can allow 10 meters for the patch cable from the wall outlet to the computer, for a total of what? 100 meters. That's the total length that Ethernet will support from the switch to the back of the computer. Right? It's not on the patch cord. It's not on the horizontal wiring. It's not on the cable from the switch to the patch panel. Is from the switch all the way to the back of the computer. Cannot be no more than 100 meters. And there's a lot of precautions that you need to do when you do the cabling. We'll see that on the next slides. All right, so here you get your guidelines for your cabling. So the termination, when you terminate a cable, terminating means making the wire connections to a jack, either a patch panel or the jack on the wall jack, the connection on the wall. You have to expose the wires, right? You need to remove the coating and expose the wires so you can make the connections. Now, you cannot leave more than 1 inch of exposed cable. And believe me, if you do that at 1.5 inches, God forbid 2 inches of exposed cable, that cable would have problems. It starts creating that crosstalk that I was telling you about, that it will create problems with your connection. You will get it connects and disconnects. You get errors in the connection. So the cables need to be protected by that shield and all together, all tied together, but no more than 1 inch. So when you cut your cables, you expose the cables 1 inch, and then you make the connection like that. Don't make exactly 1 inch. Try to make it as short shorter as you can, less than 1 inch. It has to be less than 1 inch, but no more than 1 inch when you terminate the cable. Now, each cable, and it's something with fiber, it has what's called a prescribed bend radius. The bend radius is the maximum bending or the arc that you can do with a cable. So you have to look at the specifications, see which is the bending. So when you go through a wall or through a rack or you turn in a corner, you have to make sure that you don't go beyond that bend radius. If you go beyond that prescribed bend radius, what's going to happen is the cable inside is going to get hurt. If it's fiber, the fiber is going to get damaged. So you have to be careful to do those bends, those curves, make sure that they're like wide open curves so it doesn't damage the cable. When you loop a cable, like if you're trying to do like a loop, like coil up the cable, also don't coil up really small circles because that can damage the cable if you go beyond that prescribed bend radius. So you have to make like a big loops, not make like a 4-inch little loops, make them more like 10-inch loops or bigger. You can use a continuity tester that it will test your connection, make sure that from end to end the cable is fine. Sometimes if when you're running the cable it gets snagged somewhere or it gets a twist and you pull the cable and you go beyond the bend radius, you can damage the cable. So a continuity test will guarantee that the cable is not damaged. When you tie cables together, when you cinch the cables together with cable ties, make sure that you don't tie it all the way as hard as you can, because that, again, you're squeezing the cable and you're going to damage the cable. So they have to be kind of loose. They cannot be super tight. If you're running cables on the floor, of course, it has to be covered. If you leave it exposed, one time at the Padron campus, they were doing some event and they decided to throw one of those big long cables, one of those big long patch cords to one of the doors, across one of the doors, so they could put a table outside. Well, people were getting in and out, in and out. The door was opening and closing, opening and closing. And we got to a point that the cable got chewed up from the door being jammed by the door, right? It was jamming the door, so it actually chewed up the cable. It shorted out some cables. In a way, it looped the network. So the network of the whole floor went down for like about 15-20 minutes until somebody realized, oops, the cable got all chewed up and it got shorted out and we're causing the problem. So you have to be really careful. I can't stress enough the EMI sources. 3 feet away is kind of the standard. Fluorescent lights, any motors, if it's a microwave or anything like that. Even power lines, stay away from your power. Don't run your data with your power next to each other. God forbid if you have those conduit, the pipes for the wiring, that usually you have a conduit for your power. Do not put your data on the same pipe, on the same conduit. You have to run a separate one. That's to protect the wires, right? That's to protect that. You cannot protect the power and the network together. It has to be 2 separate pipes. 1 pipe for power, 1 pipe for your data cables. Plenum is really important. If you have cable that goes in the plenum, remember plenum I said was a space right there. There's this between the ceiling tile and the floor above. That space in there, you need to, if you're running any cable there, it has to be what's called plenum rated. Plenum rated is that the sheath is actually plenum rated. Plenum rated means that if that catches on fire, the fumes that produce it, that cable plastic produce are not toxic, and also they are fire retardant, so they're not going to lit up on fire really fast. It will take a long time and it will not set up on fire easily. So it's a plenum rated. Now that sheath that's plenum rated is usually thinner than the regular cable for the patch cords, and it's not as flexible. The bend radius for those cables that are plenum rated, they're not as flexible as the regular cables. So when you're using plenum, you have to be very careful not to bend that cable too much, not to do a twist and pull it, because you'll damage the cable. Also, I mentioned before the grounding. Grounding is really important. You need to make sure that everything is grounded. Your equipment has the proper grounding. The proper grounding has to be connected to your ground, to the FPL grounding. At the Kendall campus, we did not have a proper grounding. We had to bring electricians so they could actually call FPL. FPL came and they gave us to a point that says, yeah, here is our ground reference point. And then from that point take a straight cable, like a kind of like a half an inch thick cable that we took all the way to the MDF where we have the demarc, right? To put a grounding plate, and from that grounding plate we could actually, which is a copper plate, that from that copper plate then you can distribute the grounding to other racks and other equipment through thinner cables. You don't have to be half an inch anymore, but the main cable is like that, and it provides the grounding. Now when you run the cables, you always leave some slack, like extra cable, maybe I don't know, 3 feet, 5 feet. Sometimes you need to move those cables later on. Sometimes the cable get damaged, so you need to cut a few inches and stretch it a little more to re-terminate the cable. So by leaving 3 to 5 feet of extra cable in the slack, it allows you to either move the connection you have to. Imagine if it's an access point that is in the ceiling. So if you make it just exact length, you won't be able to move it a little further away. You can move it closer, but not further away from your IDF. So you need to leave some slack. So always leave some slack. If you have too many cables and they are like tied together, it's good to use what's called a cable tray. Cable tray, it's just like a gutter where you can put all your cables, and they're laying on this gutter. It also helps to organize the cable in a way. You can, when you organize cables, you do your structural cabling. You want to lay down your cable in the plenum with what's called like a street and avenues, right? Like a street and avenues. You don't want to run cables across, in an angle from point A to point B. If you have to go from point A to point B, then you go like down, like east to west, and then north to south, or south to north, whatever, which way where you have to go, but more like in straight lines. And then that bend, remember, you cannot go beyond the bend radius, and make that connection. So you want to have everything organized. So you can lay down your either J hooks, what they call J hooks, that is like a J, like a J that is screws into a beam or something, so it will hold the cables. Those you want to have, I think it's like about 1 or 2 feet apart, so the cable don't slack and start touching the drop ceiling, so they won't get tangled up with anything else and get damaged. So either have J hooks or the cable trays. Patch panels, you always want to use patch panels. Patch panels just a way to organize and make it easier count how many cables you have, because everything will show there. Then you have to comply with, with your company standards and inventory and documentation. We'll look more into documentation, but documentation, you want to keep the cable path. You let out, label your jacks. So usually the wire will go from a specific port on the patch panel to a jack on the wall. So if the patch panel has ports from 1 through 48, you want to make sure that that jack on the wall you label with a number 1, so you know that that cable there goes to patch panel, to the patch panel and position number 1. If you have more than one, of course you have to start counting your numbers, so start changing the numbers on your patch panel. So on the next one, even though it says 1, you have to start with like 49, 50, 51, and start changing your numbers until you get if you get to 48, you'll go up to 96, and then matching labels to that. When you do your continuity test, then you can test that, that jack number 5 on the patch panel, and then you go to the wall jack that says 5, and you connect from test from end to end. You know that it is the correct cable, so it is labeled correctly. Sometimes you can use color cable patch cords to see the different purposes. We use yellow for all the data connections. If it's servers or data center equipment, we use green. It could be anything, any standard that you want. There's nothing specific. For the most part, all companies use yellow. It's the most widely used cabling, but I've seen blue, the dark blue. We use blue for data center, and the green for servers. And also we use red for all the energy management, the ones that controls energy management, that controls all the air conditioning, the lighting and stuff like that. All those connections, all that equipment is with a red patch cord. UPSs were used in white or gray. What else color we have? They were in the data center for management connections. We had, I think it was pink or purple. I think it was pink, but we don't have those anymore. We kind of trimmed those out. Everything's now connected remotely, but we used to have connections directly to the equipment, and those were pink cables. But again, that has to do with whatever is documented in your company. If you don't have a color code, then you can come up with a color code and says, from this point on, we're going to do this, and we can start replacing all the cables with the color code that you come up with. So now we're switching gears away from the cabling. So now we're going to the environment and security. All data centers and the closets need to have some HVAC system. That's for heating, ventilation, and air conditioning systems. Of course, we don't have heating in Miami, but we had ventilation and air conditioning. Ventilation because it circulates the air. It will either pump air from outside or suck the air out of the room to allow to come in through the door or from any other area, plus the air conditioning, right? So your data centers, your closets, all your MDFs and your IDFs, they all need to have separate cooling because it will be cool. They have to be cool, like I said, lower than a regular room. So you want those rooms to be a little bit cold, just so the equipment runs well. When the equipment runs at the right temperature, they will last longer. You have less problems. You have less reboots and stuff like that. You can also check the humidity. We do have some humidity sensors on all the MDFs, and we get alerts if the humidity goes too high. I think if it goes beyond 70% humidity, it would set an alarm, and we have to go and check and see if someone left a door open, so there's more humidity going to the room, or there is a leak in the room from the roof or anywhere else, or the air conditioning not working well, and the humidity goes high. And also, then you have to check on the airflow conditions. Make sure that your airflow is going correctly, right? That there is some kind of circulation in the room for the air. Okay. All the data rooms should be, any data room is supposed to be locked, and only limited people should be able to get into the room. At Miami-Dade, we do have one of those fob keys, like a card, the ID cards that is identified with a number, and then by employee, then you're allowed to certain rooms. So we are allowed to access the rooms and nobody else does. If you can, and you have the budget, you can put security cameras so you can control who goes in and who goes out, especially if equipment gets removed or something like that. So you need to add that. Here, they tell you again, 3 feet away from fluorescent lights for EMI. That will produce noise. They repeat it so many times, and I will keep repeating that many times because it is a problem. I've seen it. I've experienced that. And sometimes we're seeing problems. It goes, well, you got a cable right on top of the fluorescent lights, and you need to move it away. Oh, this equipment is too close to the air conditioning. All the cabling, it need to be moved out. So, put a little bit away from the cabling. That's where the slack on the cable comes handy, because if you have a slack of 3 to 5 feet, you might be able to move this cable away from your EMI source by having that slack, so you can have a little bit more room to move the cables. Documentation is really, really important. One of my pet peeves is documentation. I need to have everything documented. If I don't have it on paper, I cannot work on it. It makes troubleshooting so much easier when you have to look at a design or any problems that you have. Having a document, it will make things so much easier to look at, and it just a documentation. You're not going to be able to remember everything unless you have a small network. But even with a small network, I help maintain a small network at a private school. They do have a router, like about 3 buildings and I don't know 7 switches and things like that. I don't remember which port is being used and what room are they in, what's the IP address of all the switches. So if I have a documentation, then I can see where things are and make things a lot easier. And when there's a problem, all I have to do is to grab my folder, pull out that drawing, and see it and work on it right away. It could be a logical design, it could be a physical design, but at least to have some kind of documentation tells you what is on your network and how things are connected together. So there's several ways you can do this. You can have a network diagram, right? There's a graphical representation of everything on your network, how everything's laid out, your topology, your IP addresses, names of devices, and anything that is there. Even the type of media, if it's fiber, if it's a cable, any anything that you can have on that diagram will show you everything. At the college, the network is so large that we have the diagrams by room, by building, by areas. It depends on what you have. You can also do a network mapping. A network mapping is just a software that will go out and it will identify the devices, and then it actually makes a query on the device to see, hey, what are the devices you see connected to yourself? What are the neighbors you have on your net as a device neighbors, and then start building a map based on that, which is very accurate because the information is coming directly from your devices. What happens is sometimes these softwares don't know the whole picture, how everything goes. So if it's a large network at Miami-Dade, if I try to run a network mapping, it will come up with like some kind of spaghetti that is lines everywhere and lines across, thinking that since it's looking at it from the network point of view, a logical connection might be represented as a physical connection. You know, like if I have a connection, I don't know, from Homestead campus to the North campus, there is a logical connection there, and the network mapping tool will show you that connection. Oh, look, these two pieces of equipment are connected to each other through this link, but physically they're not. Physically, it's just a tunnel connection, you know, all the way to north. When you VPN to the college, your computer thinks they're directly connected inside the college network, right? If you run a network map at that time, the mapping will show you, oh, sure, you have a connection to Comcast, and you have a connection directly to Miami-Dade, and it will show a wire between your computer and the Miami-Dade network and everything inside Miami-Dade. But it's not really like that, because that's a logical connection, not a physical connection. So network mapping, it is, I mean, I use it to verify that my diagrams are correct, but it could be deceiving sometimes. So you have to know your network exactly. And then when you create all this, there's some, Cisco created some standard for the diagrams that you can use on the network. And we'll show you some ahead on another drawing, so you get familiar with those symbols for each device. Yeah, Nmap is one of those utilities. You can run it on Windows and it will map your network. But I don't know. Even on my home network, which is a small network, I run Nmap, and the Nmap just comes up with things that are not really there, connections that are not really. I don't know. I don't trust those mapping tools. You like I said, I can use it as a reference to verify that my diagrams are correct, but I don't rely solely on those mapping software. Nmap is okay, it works. In my home network, it took forever to run. It took like 2 hours. My home network, imagine if I tried to run that at Miami-Dade on one campus, it would probably take a month to run. But so I don't even try doing that. But it is there and something a tool that you can use. So once I map my network, it will look something like this, where I identify where the internet comes from my provider. Then I have my firewall. So I see a connection going into the firewall, and from the back of the firewall going to my internal router. On the firewalls, the side facing the internet is called the dirty side. Dirty side because everything goes through there, and then the firewall will do some filtering of what can go in and what cannot go in, and it will block some of the traffic to go in. So on the right of that, you have what's called the clean side. Clean side is already sanitized, right? It's already sanitized traffic, that only the good traffic that you want inside your network is the one to go through the firewall. So once you pass to the clean side, you go to the router. You see that a symbol for the firewall. That's one of the standard symbol for that. And the router also, you have that like a hockey puck, and you see the arrows. They have 2 arrows pointing out and 2 arrows pointing in, meaning that this is a router. It routes traffic going in and going out. Then it goes to the switch. The switch is just like a pizza box. The pizza box, you see that it has like a bus in the middle, and it has arrows pointing to the outwards, right? So because the switch takes one middle point and it is distributing signal. And then you have your connections to your workstation, your printer, your file server. Then you have the wireless access point, and the dash line. That's because it's going over the air. It's the radio frequency, so you can identify that through a dash line. The access point, you see how it has like also a box with circles on the front. that would identify like an access point. And then the workstation, they just like the normal, workstation diagram with a tower computer. It might not be exactly like that on your desktop, but at least it's something to identify that. Myself, I just kind of like draw like a screen showing that that's a workstation, like a screen and a screen and a keyboard. And that, to me, that's that's enough for a workstation. But switches, yes, switches, you'll use that like a pizza box with the lines on top, and the router is like a round hockey puck, like three-dimensional. You can see it like that, and with the arrows pointing out, pointing in, meaning that it routes traffic. Remember that the firewalls will work on the higher OSI layers. They work on 5, 6, and 7, so they can do all that filtering there. The router will do layer 3 and understands layer 4 for your TCP and UDP ports, right? That's the layer 4. And then it goes to the switch. That's, of course, see, we're going backwards now. Firewalls will do the upper layers. So you go to a router. Router handles layer 4, layer 3. For layer 3, it will pass it along to the switch. Switch works strictly on that layer 2. And then it will deliver layer 1, which is the cable, all the way to your workstation. So this is why your layers are very important. Like I said, the switch layer 1 connects to the layer 2 on the switch, passes along to the router, layer 3, layer 4. Remember, that was the network layer and your transport layer. Transport is for the TCP connections or UDP connections, and then goes to the firewall for the higher, sessions and the application. So you can have different types of diagrams. You can have your network diagram, which is kind of like a overall picture of your network, everything that you have, physical, logical. It could be either way, or a combination of both. So you can see when you want to do expanding your network or just troubleshooting, you can see the kind of like a view of your whole network and take it from there. Then you can have your wiring schematic. With the wiring schematic, it actually identifies all your wire connections and connections between devices, the interconnects, and it represents the physical wire infrastructure of your network. And then you can have a rack diagram, which is just like how devices are installed in your rack. Remember that I said that you can have your fiber on the top, your routers and switches, your patch panels on top, and then underneath, like towards the middle, your switches, your routers, and things like that. And then at the bottom, you got your UPS. So on that rack diagram, that's what you want to see. Usually for space-wise, just to see where things are laid out. If you want to plan to put more equipment, then you don't have to, let's say, God forbid, it's a North Campus, walk all the way there to see what's in the rack. If I have a diagram from Kendall, I can just open it up, look at it, and goes, oh, this is what we have at that rack at North Campus. So we have, I don't know, position 17 and 18 available, and I can put my switch right there. And we're going to put a wire management on 19 because there's a space there, right below the other switch that is there, and run the cables and like that. So it's for planning and just to have documentation, so you don't have to be going all over the place just to see where things are and how things are connected. But those are important to have. All right, so this is an example of a network diagram. You see on the right side, on the top, your connection to the wide area network. I mean, that could be wide area going to another location, or it could be your ISP, right? It has multiple uplinks. The uplink to a 24-port gigabit switch for your wireless router, and there's another PoE gigabit switch in the middle, and toward the left is another 8-port switch, and all those are being uplink to that main switch. Do you see how that first switch does not feed any computers? That's your center of the star. That's the switch or the device that's going to distribute the signal all over your enterprise. So you have 3 switches. The 8-port fits some computers and some file servers. The middle switch with the PoE fits, the voice over IP adapter for phones, and your voice data gateway is connected there too. So it's a good switch, so be able to handle the gateway. And then on the right, you got a 24-port switch or workstation. So I guess this network is segmented. I guess the switch on the right feeds the workstation. The switch in the middle feeds only the voice, and the switch on the left feeds your file server. That's where you have the printers, and that could be your data room or your data center where you have those file servers are protected in a different area with more security in the room. So see how you got 3 switches feeding different areas, and they're all segmented. The switch is making that separation between all of them. But looking at this diagram, now you see where workstations are connected to which switch. So this could be 3 areas. It could be that all these 3 switches are on the same rack, not on an IDF. So imagine you have a small business and you have just one room, which is your MDF, and from there everything comes to that room. Then you have multiple set of cables going out for the servers, one for the voice, and another set of cables to that. So if you have everything documented and labeled correctly, when there's a problem with a workstation, then you can go straight to that switch that is only for workstations. That's where you need to have everything documented and everything labeled correctly to identify that that switch is for workstation switch. The other ones are the your voice over IP switch, and the A port on the top left, that's your data center switch. So everything, nicely organized, nicely labeled. So when something happens, you don't have to be running around chasing cables, pulling the cable and see, oh, where's this cable going to? Where does it terminate? Everything is nicely documented. You can see it there and visualize it. And this is the network diagram for a rack diagram, where it identifies that the switches are on top. You get your patch panels, and then servers are in the middle, the security appliance, and then the UPS at the bottom. And this is the total rack. It doesn't show the how many U's they're using. Normally, I like to put uses to see what U's are being used. There's some in the middle that it's like a 1 use. Between the UPS and the security appliance, and between the patch panel, the service, another U, between the switches and the patch panels, another available U. So that's just documentation, just to make sure that when you need to look at what you have, is at your fingertips. You'll open either your share folder where you have on the network, or you open your folder with all your printouts, and it'll be there. I decided to include this example. This is the small network that I support with one of the Catholic schools, a private school. And if you see, it started from the top middle, it says HRS firewall. So the firewall comes in here, and it has a 1 to Comcast, the one connection to Comcast. It comes in, and see I have P2, that's port 2. Then on the left, I got P1 LAN, goes to the MDF switch 1. So that means that's a switch inside the MDF. And that switch is a distribution switch. You see, it goes to the wireless controller. It goes from the top left to the directory R1, and that is from port 9. And in the middle is a fiber link. There's some fiber link. The blue means, I guess, that's a cable. That probably, I think those are cables. They're showing blue. And then down below, you got an MDF R1. So there's a router there. Remember that router was only routing the traffic for the wireless. So it was installed there. So it's more like an in and out thing to see that one goes VLAN 1U, and then the VLAN 40, that's for the users. And then down below, you got the admin building switch 1. So that means that switch is in the administration building. It labeled port 49, I think. Yeah, 49 is with a blue cable that goes to port 13 to that MDF switch 1. So if I'm troubleshooting anything and I'm go to the MDF switch 1, I can see if there's a problem with that uplink or something like that. So I can troubleshoot that quicker. And then the two red lines in the right hand side, those are fibers. They're in red because those are fiber going to the elementary school building and also to the middle school building. And there's 2 more switches there. One is more like a chassis, the one for the elementary school. So I have my IP address. I see that it comes in on port B21. That's the uplink. And that B21 on the elementary school switch goes to the MDF switch 1 port 23. So it's all documented there. So if I have a problem, I can look at this diagram and I can see everything. And also on the middle school, you see there's 2 more switches at the bottom. The middle school switch 2 and switch 3, SW2 and SW3. That's, I guess, I think that was fitting one of the computer labs. Another thing you can notice here is the naming convention that I'm using. It's kind of long, but still, you got rectory R1, router 1. MDF R1, because that's the only router I have on the the MDF. If I have another one, it will be probably R2 and R3 and R4 like that. In the middle school, in the middle, you'll see they have middle school SW1 for switch 1, then SW2 and SW3. So that way I distinguish the switches. Then I can document what, like if I said, if the computer lab goes to switch 2 and switch 3, and they have a computer problem and they said, oh, reboot the switch might be having problems. Well, I'm not going to reboot switch 1 because it's not necessary if the ones having problems is switch 2 and switch 3. So reboot those two only because I know that they feed only the labs. And then if the whole building is having problems in affecting also the computer labs, then I would probably reboot switch 1. So that would actually reset everything of the whole building. So documentation is really, really, really important. And it's something like this. It just gives you like a broad view over where things are connected, the port numbers, and the type of cable, if it's fiber or a cable, and any troubleshooting, then you have like the whole view or the whole network right there in front of your eyes. So for operating procedures, there's documentation that you need to have and some things that you need to have that's essential for any operation. Of course, you need your diagrams, right? Your logical and physical connections to the network. You might want to have an inventory of your equipment, model numbers, serial numbers, data that were purchased. Some of this equipment will have software in there so you can keep track of also the version that is running. So you can check and see if there's any new release and you need to update and how many of those you have. And if you have, I don't know, 10 switches, are they all running? Are they all the same model? Are they running the same software? They're running different software. So you want to make sure that all of them use the same thing. IP utilization, you have to make sure that your subnets, the way you have your IP addresses distributed, you might want to segment it. At the college, when you have a range from 1 to 255, we try to put things that are always fixed, and you want to keep the same IP address always allocated for a device. We want to keep on the low range, the 147, 70, 40, that 10, 11, 12, 13, something like that in the lower numbers. If it's a printer, we try to keep it in the upper range. So it's 50, 51, 52, all the way to 55. If I have more than 4 printers, then I'll start going to the 49, 248, 249, and like that, 247. But it's all on the upper range. If I see a printer on a 147, 70, 40, 175, I'll be like, why is the printer doing in that range? It should be on the upper range. Not because it makes any difference. They all work the same. It's just organization. You can also document the vendors, what vendors you have, or what communication you have with the vendors. You have any contract with the vendors? What's your contact with the vendors? What kind of level of agreement you have with the vendors? All that information. Operating procedures. If something happens, who reacts to what and when, and in what order? At what point level 1 support calls level 2 support to escalate the problem. If the problem gets bigger, then who does it go to? Also procedures that who you need to call, who you need to report the problems. At the college, we do have the escalation procedure that if there's a problem, I try to contact the techs. If the techs are not there, they try to contact people that work in my area. If they cannot contact any of them, they'll try to contact me. If they cannot contact me, they'll contact my director. And if they cannot contact the director, they will probably go to the CIO, the Chief Information Officer, which is the top person in the area. You don't want it to go there. That's the top management. They don't know how to fix it, but they're the ones start calling people to, hey, what's going on here? You also need to have your policies and procedures. How you supposed to behave, how you're supposed to treat your equipment, what equipment you can have, what software you can have and not have, or any type of procedures, and your standards. If you set up a standard for everybody mostly uses Office. So if you have a standard, everybody needs to communicate with Office. Well, now for conferencing, now with the pandemic and all this remote work and all that, companies had opt for Zoom. Some people opt for WebEx. Other people are using Microsoft Teams. The college is using Microsoft Teams. We do have Zoom. Some of the professors like to use Zoom, but within the departments, we use Teams. So it's a standard that was already set up, it's supported. If you have any questions, you got people that can help you. But using something that Citrix. In the college, nobody uses Citrix, but someone decides, I want to use Citrix to communicate with other people. And we're like, well, we don't support that. Is that the standard? No, nobody's going to have that. If you want, you can use it. You're on your own. You cannot call me for any help. But if you're using Teams, I know Teams. Everybody knows Teams. So anybody from my department can help you. Um, so many companies establish that the standard operating procedures, to make sure that everything is done accordingly. Even for the standard procedures, like not only for problems, for installations or how do you conduct, new projects and anything like that, and the process to get your cabling, to get your equipment, to get everything done, right? And also, yeah, you should have some kind of website or database to hold that information so it's available for everybody so it can be shared. You can have just like a share folder. And we have a infrastructure share folder. Under the infrastructure, all the information is there. There's one folder for network documentation. And I have most of my documents are on network documentation. That's where I put my documents. But infrastructure also have stuff for the voice over IP, for all the servers and things like that. So we do have a share folder for us to share information. So part of keeping all the documentation is for inventory control, right? You want to be careful, keep track of your the life cycle, the SLC, the system life cycle. That's for designing, implementing, and maintaining your equipment to make sure that when the equipment is going to be outdated, you can run equipment that is old, but it's no longer supported. It's not compatible with new devices. So sometimes you need to update your equipment. As a rule of thumb, it's something that is over 5 years old is starting to get old. Something that's past 10 years is already considered somewhere in the edge of being obsolete. So if it's over 10 years old, it's something that you might want to remove out of your network or plan to remove it out of your network. So that's why once you pass the 5-year mark, then you start planning, what am I going to do next? What is going to be the next release of equipment? Where are we going to go to? What am I going to replace first? So that's why you need to keep that inventory management to monitor your network, make sure that you have everything there. I do have a server from Cisco. It's a collector that what does, it goes out to all the Cisco equipment and it collects information out of the Cisco equipment, and that will give me a nice printout of the equipment problems. If there's anything reported by Cisco, if it will document the software release that is running, so it can actually provide me, said, hey, by the way, this software release has all these issues, you should upgrade to this release. Or might say, yeah, there's a new release and the Cisco recommends to install the new release of software. So that helps a lot to keep everything in place. And also many times you want to maintain maintenance contracts on some of the equipment. So if anything fails, you can just call the company and say, hey, I have a switch that went bad, I need to have it replaced. Depends on your contract, they might replace it within 24 hours or 48 hours. Depends on the contract that you have. They will send you a replacement equipment. And all you need to do is to reconfigure it, put it back in, you're done. So, but then you need to keep all that inventory, so you're able to, in order to have all those services available for you. Well, this book likes to jump around a lot, but anyway, this now is going into the labeling naming conventions. Remember my example diagram with the MDF switch 1 and the MDF R1 and the middle school switch 1, middle school switch 2. When you name your devices, they should be named with a description, more descriptive as possible. So it's short, but it tells you what it is. I mean, by having middle school SW1, it's the middle school building, and it's the switch 1. There's another one that was the element, ELEM school, and for elementary school, switch 1. So that's not the middle school, it's the elementary school building, and that's SW1 for switch 1. Remember that I had the MDF R1 and had a rectory R1. That's a rectory router 1 and the MDF R1. If I had more than one router, of course, it'll be MDF R2, R3, R4. Some of the routers that we have from Cisco at the college, they're route switches. So those we call them RS1 and RS2 and RS3. So it's a route switch. So we distinguish routers that just plain routers from the route switch routers. So you have to establish the naming convention. Sometimes, like what the college use is the room numbers where the equipment is installed. So if I have an IDF like in building 8 where we have the classroom is 8216. On 8217, inside 8217, there's 8217-1. That's a small room in the back, and that's our IDF in there. So all the equipment there is actually labeled K for Kendall, 8217-1 SW1. So I have, so by looking at that name, I know it's Kendall. 8216-1 is the room, and then it's a switch 1, so that means the first switch. So if I have 7 switches, I might hit switch 4, switch 5, switch 6, depends on how many I have. So it should be short, but something descriptive, right? It's also, I have to make sure that the UNAMI convention doesn't give you too descriptive, like if it's the main web server. So you don't label it main web server, main web server, or main web SVR1 for server 1 and SVR2, something like that. Sometimes you don't want to give also too much details that you can compromise security for someone that walks in there. The tags can be different colors for different things. Like if you label the ports, there should be different labels. Labeling the jacks and the ports, like I said, everything should be matching. Something descriptive. Here at the college, the wall plate on the top will have the room number where that cable is going to. And then each port will be labeled with the patch panel number. So patch panel, we call it D for data. So you got like D41, D42, D43, D44. That's for your data. And then in the middle, at the top of the plate, you'll have the room number where that is going to, which IDF. So by looking at the wall plate, I know exactly where those cables from the back of those jacks, where that cable is going to. Okay. What else? Labels should be durable and designed, to stick to metal, plastic. Make sure that you get some labels that you test them, that make sure that they can extend time. Sometimes these labels will stay there for a long time, 5 years, 10 years. So you want those labels to stick, not something that you glue in and then a year later it falls off. Just make sure that you have some good label. You can buy the labels, cable labeling. You can sell there are all kinds of labels, or you can there's some cable that wrap around the cables, and there's special labels for that will last. It will last a long time. So these are some examples of the labels. You see how the patch panel got renumbered. It says E774, E775, E776. I guess E for Ethernet, I'll guess. And you see different colors for the cables. And some of those, like the green cable and the white cable, has like a little label on top. It doesn't. You can't see what it is, but that cable might be labeled for something. On the right, that's a fiber that's being labeled, and you see that E632, P2, 3, and 4. I guess is some connection that goes to E632. Is for the P2, P3, and P4. I don't know what that means, but you'll see that something. I can't read it, that one, but it says PERS2C223. So yeah, you can have the label, the descriptor, where it goes to, where it's coming from. Sometimes we label like that when it's really long cables. It will label where it's coming from and where it's going to. The device with the port, to device and port. So at least on both ends, I know that I'm on this switch. Let's say on this elementary building switch 1, then it has a label that goes to the MDF switch 1 port 13. So that way, when I go to the side, I don't have to, I can see it on my diagram. But if I don't have the diagram, I can rely on the labels on the cables themselves. Very, very handy. Now, if you want to label your equipment, you can put labels there. The squares will be kind of your ports, the ETH1, ETH2, ETH3, ETH4, and you see that they can put a little label that shows, the IT, HR, accounting, and sales. So again, if you don't happen to have your documentation on hand, or if you do, you can still verify. They said, oh, I need to disconnect port 3 because that's the one going to HR. When you go to the router or this device, you see that port 3 is with a label that says HR. You're like, oh, yep, it's correct. That's what the documentation says. That's what the router says, and then I'm looking at the right cable. And then the slot 1 is when it says 2.1 to the wide area network. So that's maybe going to your provider, but it is labeled there. I don't have pictures of the some of the equipment at the college that will show that, but we do label some of the connections like that. Not everything, but some of the connections, just to document it correctly for easy, you know, finding something easier. Okay, and the last portion is part of the business side. These are some of the terms that you need to be familiar with. Um, the RFP is a request for proposal. That's a request from the vendors submitting a proposal for a product or service or equipment. If I'm going to do a purchase of equipment, I would actually create a RFP, a request for proposal, give it out to multiple companies. I said, hey, I want to replace the wireless at Miami-Dade, and I have, I don't know, 20 buildings, and each building has 4 floors, and I want to connect Wi-Fi everywhere. So can you give me a proposal? How much it will cost me to do that? So the companies will have to reply to this RFP and with the quote and their designs and things like that. Then you can have also the MOU, the Memorandum of Understanding, right? This is the understanding, is an agreement between the two, that what is going to be each one of them needs to provide, and what each one of them is supposed to, what part which role they play on that agreement. It's like it's a contract, but it says, hey, okay, I'm going to provide the wireless, but Miami-Dade needs to provide the cabling for us. We're going to tell you where the cable is needed, and then you provide the cabling, we provide the wireless. Because, I don't know, it might be a company says on the RFP, I can provide you with the wireless, but I'm not a cable company. So you provide the cable. So you create a memorandum of understanding of what part I'm responsible for and what part you're responsible for. Then they can provide you with an SOW, with a SO. Some people call it so. I always call it SOW. It's a statement of work. That's the document that details exactly what the company is going to do for you. And when I said exactly, it means exactly. They won't do one thing extra unless they modify the SOW and charge you more. They can do less, but they will do exactly what it says there. So if it says I'm going to run and install 50 access points, and you're like, oh no, but this area has a little more, we need to install 2. It's like, no, my statement of work says I'm going to install 50 access points. So which of the 50 you want me to install? Or if you want to provide some kind of a statement of work for an upgrade, well, I'm just going to upgrade and install the new software and make it work. But if you have a problem or something that you want to add to the application, some new features or something like that, that's not part of it. The statement of work says, I'm going to upgrade your software and I'm going to get you running on the new release of the software that has new features, but I'm not going to provide you support on the new features. Now you can get another contract to do that. So the statement of work is the one that says exactly what you're going to do. And then the SLA is a service level agreement. Service level agreement is kind of like, it's a legal binding. It says, what kind of service are you going to provide? What do you can expect from me? Usually on an SLA from Comcast or AT&T, so they will tell you, we'll provide you internet 99% of the time, which is, it sounds good, but 99% of the time in a year, right, means that they could be down for like 3 days. Because if 100% is 365 days, 90% of that is 360 something. I can't. I don't have it computed right now, but it it means that through the year they can be down for 2 or 3 days, and you're still within the agreement. I can't complain or anything. So that's why when you do an ISP, you can have what they call 5 nines, which is 99.999 5 nines. Of service, which means that you're gonna be down for such a small period of time that I'm not gonna notice. I'm not gonna have any problems. Just like a hiccup on the network, and that's it. So you get the 5 nines, like 99.9999, 3 nines after the period. But the SLA, you have to be careful because the SLA will do that. It will be up. Like the SLAs that Comcast gives to you. Comcast says we'll provide you with the best effort. Right? We'll provide you 100 megs at best effort. Well, best effort means that they'll try to give you 100 megs, but they don't have to give you 100 megs of throughput because it's just the best effort. They'll give you 80, 85, maybe 90. You'll be lucky if you get 95, You will not get the 100 megs, but because they're doing the best effort to provide you 100 megs. But the maximum that you will get will be 100 megs when they do the best effort. Like I said, they can be 80 megs, 85 megs, 90 megs, but not the 100 megs. So that's why you have to be careful when you do that, because sometimes you might run out of space and throughput, and you say, oh, but I'm paying for 100. Like, no, 100 best effort. That's what the SLA says. And that best effort means that we'll try to give you 100 megs, but that doesn't mean that I have to give you 100 megs. Like I said, 85, 90, something like that. So SLA, important. Then you have this two, the MSA and MLA, the Master Service Agreement and your Master License Agreement. Two separate things. One is service, of course. One is a Master Service Agreement. It is a contract that defines, services they're going to provide to you, right? For all the contracts. And then you got a license agreement that just create licenses for your equipment, for your product, any distribution of your software. If we have a master license agreement, let's say with Microsoft, that means that we can have Windows 10 installed on, I don't know, 10,000 machines. So we got a master license agreement that he said, hey, you can install whatever you want, but we'll give you 10,000 licenses. And with those licenses, we're going to give you also licenses for X product that's part of this. So that's your master license agreement that you can have. And then separate for the service agreement, service agreement is a contract for services rendered to you. Could be support, could be hardware services, warranty services, extended warranty services. All that's part of the MSA. Now, change management, that's also a good part. Change management is just to create more organization and make sure that the flow of the changes that you do on your network are documented, are done efficiently, and are done with the best practices when you do something. So it could be for installing something new, doing a new product, installing a new service, or also installing patches or replacing equipment on your network, right? So there's always, you need to have a procedure, to do your change management. There is also what is called, I don't think it's included here, but it's what is called separation of duties. So separation of duties, what it is that there's some parts of a procedure that one person does, and then the other part of the procedure, the other person does. So you need the two parts to be complete, but now you don't give the one person the full power to do everything, or the second person to the full power to do everything. They all have to depend on each other. So you can have two departments that one handles one part and the other part handles the other part. So for example, someone might give you your user ID. So Miami-Dade, hey, you got your user ID. So you got this department that all they do is get your information and create a user ID. That user ID doesn't mean you have any access to anything. It has to go to another department. There's the one that provides you with the access when you have that user's ID. But this department that gives you access cannot create user IDs. So they cannot take someone and goes, I'm going to create a user ID for Juan. I'm going to give you access to all these things. Like, no, they can't, because they don't have the power to create accounts. But they can give you access if you have an account. Whereas the other department, they can create accounts, but the account is useless if you don't have access to the services. So that's when you have separation of duties, and then that's when you require a change management to say, hey, okay, I need to create a new user. This is the information. So with the change management, you provide the documentation, said, hey, create that account for that user, and then with the procedure goes to the next department, because okay, now that the user is created, this user needs access to this and this equipment. So when you do the change management, that's what it is. It's a procedure. So you see how things are being done. Now, when you do software changes or hardware changes, you can do four things. You can do an installation, which is installing new equipment or new software, right? That's an installation. Like I said, even an application or equipment. You can have a patch. A patch is a correction, an improvement, or enhancement. Something that it has a minor flaw, and you want to patch it. So you patch that connection. You install a patch. So some of the software releases, they're released as a patch. Windows puts a lot of patches, right? For the software. And then you have an upgrade, which is a major change. An upgrade could be now from Windows 10 to Windows 11. If you're talking about a router or a switch, the operating system has also upgrades. Usually they go by release numbers. So you might have release, I don't know, 3.14. So 3.14 might go to 3.16, but that's usually a patch because the 3 doesn't change. So it's still running kind of like release 3 with the patch 14 and patch 17, patch 18, patch 19. When they do a major change and they will do a major software change, what they might do is change that 3 to a 4. So now you're not on release 3, but you're now on release 4. And they'll start with 4.00. And you upgrade to 4.00 or sometimes 4.01. And then they'll start releasing patches on 4.03, 4.05. If it's a major patch, they might just go to from 4.05 to 4.10. So now you see the jump from 5 to 10. You could then add the second digit change. You're like, oh, that's a major patch. So, but those are patches. So the patches are correction, just something minor, and then the upgrade. Now, if something goes wrong with that upgrade, or even the patch, you can do a rollback. With the rollback, it's just going back, downgrading to the previous release. Usually you revert. So usually when you do a planning for an upgrade or a patch, you have to have some documentation or something to say, okay, if this fails, how do I roll back? Because if I'm in the middle of the night doing an upgrade to a router or patching a router and something fails, I cannot leave that in failure mode. I need to put it back the way it was. So I need to also plan, okay, if something fails, how am I going to roll back? So that part is so part of the change management. So when you do the planning, change management has to include, say, hey, okay, I'm requesting that I do an upgrade on the router that's running, 3.12, and I want to run the upgrade to 3.14. And this is the procedure to do the upgrade. If it fails, I need to roll back to 3.12. So these are my steps and my procedure to roll back and leave it the way it was, like if I didn't touch it. A website, if I'm doing a change on a website for something, some of the portions that I need to change, I need to also find a way to do a rollback. So if something fails, I can put it back the way it was, and hopefully everything will work again and nothing breaks. But that's part of the changes. But be familiar with what they mean: the installation, patch, upgrade, and rollback, because those are really terms that will come up on your everyday life in IT. So why we want to do this? We want to do this because the process has to go through the proper channels. Many times you need to get approval from your supervisor, or someone else need to look at your procedure set and approve it. Normally, even if I'm going to make a change, there's another person that works with me on the routing side, and I can explain to these co-workers that, hey, by the way, this is what I'm doing, and this is my procedure, this is what I'm going to do. That person will look it over, and it goes, well, you know what, it looks good. I think your procedure looks fine. So I get more like a reassurance that what I'm doing is right. So we always do that, because then when I submit it, I say this was submitted by Juan, and it was reviewed by such and such. So this person, not only that I wrote it, but somebody else reviewed it already, and then I submit that for approval. And that's just to make sure that nothing goes wrong. That's to minimize impact. The beginning of classes, the first Wednesday, our website went down for like about an hour, the main Miami-Dade website. And that's because they did an upgrade. And they said that it was tested, but for some reason when they implemented, it failed. So they were trying to patch it, try to fix it on the fly, and that wasn't working. So at the end, after like an hour, so you know what, guys, this thing is not working. We need to roll back. We need to find a way now to roll back the way it was and put this thing, and forget about that patch. We'll do it some other time. We have to roll back. So, everything was documented. It's like, okay, let's roll back. And it took us like 10 minutes to roll back to the old setup, and everything came back up. Why? Everything was documented and approved correctly, and it was done like that. So, what you want to do is make sure you have everything tested, documented, so when you try to do it, it works the first time. You don't want to be testing things in the middle of the night or testing things in the middle of the day. God forbid, in the middle of the day, trying to do a change you've never done in your life or never done before, and you don't know if it's going to work or not. You want to make sure that it's planned correctly. If you can test this on another, mimic that test on test equipment, you can do that to make sure that it works. And then you document everything, all the changes that you do. I tend to write notes as I'm doing something, because if I need to do it again, then I have my notes, or if I need to go back, I can say, okay, I did this and did this. It's like, oh my God, I stepped over this thing. I was supposed to do this before that. Or I can have my procedure that I go A, B, C, D, and then when I'm doing it, it's like, oh, I cannot do B if I don't do C first. So I kind of change my notes and revert and do it right, doing testing procedures. So the day I do it, I don't bring anything down and everything is documented. So next time I have to do it, I got documentation. So all that is really, really, really important. I have tons of notes of work that I've done 5 years ago, and all of a sudden I have to do it again. It's like, oh, I got some notes, and it's all documented how I did it, and I documented problems that I had, so we don't have that problem again, or we don't have to reinvent the wheel and do this thing and research the procedure all over again. So documentation is important. So the procedure changes, depends on your organization, how things are organized in your company, but for the most part, yeah, you submit a change request. Then you follow the approval process. It might go to a project management to see if you require multiple areas to be involved, right? I told you that when I mentioned that the website went down at the beginning of classes, we were 13 people connected on the call, and there was at least 1, 2, 3, 4, at least 5 different areas that were represented in that call, and we're all doing or checking something that it pertained to our area, so we can all work together. So that was part of the management procedure, the flow of who what's that, what goes where, who does what part, so we can get everything working. So, and then you have to provide your documentation. Like I said, it depends on your company with the network utilization, the IPs, the additions to the network, the physical location where things is gonna go, and then you close the change. The way I write my documentation is thinking that something happens to me. Let's say, God forbid, I get into an accident, or I just get sick, I don't feel well that day. I can actually give that documentation to any of my co-workers, and they can follow everything. They have my procedure, and it says do this, do this, do this, do this. Install this file, which is at this location, so the file's already there. Do a backup, store the backup at this location, and da 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 da. If something fails, the rollback procedure is this. Go to your backup that was there, name such and such, and restore it like this. I put commands exactly how they need to put it on the command line for 2 reasons. If something happens to me, somebody can go take that documentation and do it themselves. And also the day that I'm doing it, I don't have to think about it. I already thought about it many times before doing the change. I already tested it, I already tried, I already did some mock testing to make sure that everything was going to work. So that day that I'm doing the upgrade, all I'm doing is follow my own documentation and say, okay, do this and do this, and it goes a lot quicker, and I know for sure that things are going to work. You still have to be careful. Something you might skip here and there, but for like 90% of the time, everything is documented correctly. Like I said, and it's all approved. Everybody knows. I notify the campuses, I notify directors, I notify everybody that will get involved that would affect them. I notify them ahead of time. Hey, this day we're going to be doing this upgrade or this change, and just to let you know, we might be down for 5 to 10 minutes. I know I need to do a change that I'm going to disconnect the internet to the college, and it's going to be down for like about 30 seconds if everything works well. But I need to also document that, present it, get it approved, plan the day that I'm going to do it. Of course, this is going to be like a middle of the night, like a midnight thing, that I have to show up like at 11, prepare everything, and at midnight, boom, pull the connection and bring things down. Now, granted, if you're on Blackboard, students can connect at midnight, and it will happen. You'll lose the connection. But I'm trying to minimize it to make sure that it's no more than 30 seconds. And I cross my fingers and make sure everything works well. But if I affect any of those students that are connected in the middle of the night, I will. But it's, for the most part, teachers will leave tests at night on weekends. They have up to midnight to do it. So if I do it past midnight, it's kind of safer not doing like a 10, 11 at night. So I'll do it like a midnight. So, but then like I said, it depends on the procedures on your organization, or how things are organized and how they set the procedures. Some places you have to go through a ladder of like 10 steps to 10 people to get something approved. Some other places just like 2 or 3 people. At the college, I'm close to the director, so many times when I get to my level, when I need to get his approval, maybe one more, and that's it. I'm already part of the organization part, so I can actually guarantee that this is already done, review and everything. So it basically has my approval. So it goes to a few more layers, and I'm done. Okay, so this is the end of the chapter. Um, So review all the material on the book if you can. There's more stuff in the book that I cannot cover everything, because otherwise I'll be talking for hours and hours and hours. So you're gonna fall asleep. Then in class I will go over some of the this material again, more like an overlook, and a little bit more examples on the material. But thank you for listening, and thank you for your time. And we'll continue in class with this chapter. Thank you.